Good morning, everybody. We're going to continue looking at some parabolas today. We're going to be mainly looking at the graphs of them and the different features. So we're going to do a very brief dive into section 6D. We should have gotten most of this from the bell ringer, but just to kind of reiterate, so if the a value on your parabola is greater than 0, you're multiplying x squared by a value greater than 0, a positive number, that's going to create a shape of a parabola that opens upward. If it's negative, that's going to reflect it downward, and that's going to create a parabola that faces the opposite direction. It's going downward. And with the value of a in terms of what the actual raw number is, if the absolute value of that is a number greater than 1, it's going to stretch your graph. If it is a number between 0 and 1, it is going to compress your graph. So we're not going to do too much with that. We're going to use these facts later on to help us graph some, but let's keep that as a reference for when we do start graphing some of these things. So we're going to start by looking at the graphs of some of these quadratic functions. So we can sketch a graph of a quadratic function by considering the value of a and the axis intercepts. So the x-intercepts and the y-intercepts. These are going to be some of the things that we use to help us graph these parabolas, these quadratic functions. So let's use this information to help us graph this right here. So we've got the function y equals x squared minus 3x minus 10. So right off the bat, our a value is 1. So this tells us that it's going to open upward. It's going to open upward because the a value is positive. So now we need to find the x and the y-intercepts. So for the x-intercepts, remember last class we talked about if it's an x-intercept, and we're going to graph this anyways, so I'll go ahead and draw a graph. If it is an x-intercept, it crosses the x-axis at some point, which means that the y value is going to be 0. So to solve that mathematically, I'm going to set this y value equal to 0. I'm going to say 0 equals x squared minus 3x minus 10. And I'm going to solve this equation by factoring it. So let's see, things that multiply to negative 10 and add to negative 3, that's negative 5, positive 2. So that's going to factor to x minus 5 times x plus 2, which means I can set each of these factors equal to 0 and get my x-intercepts of negative 5 and positive 2 here. So give me 1 second. Oh, that's going to be positive 5, sorry. And x equals negative 2. So we've got 1, 2, 3, 4, 5. There's an x-intercept right there at 5. Here's an x-intercept here at negative 2. And now we need the y-intercept. So again, for the y-intercept, if it's crossing the y-axis here, it's going to have an x value of 0. So we're going to say y equals 0 squared minus 3 times 0 minus 10. So 0 minus 0 minus 10. It's just that c value. The y-intercept here is going to be negative 10. So I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is clearly not drawn to scale. But I did say to just sketch it. So we know this is going to open upward. We know it's got to pass through these points, so we can use these features to try and get a parabola. Now, is that perfect? Probably not. But we have a general idea of what that graph is going to look like. So let's try this for a few more graphs really quickly. So we've got this function here, so this is actually in what we call factored form. We've talked about this a little bit. That's y equals a times x minus p times x minus q. So again, we have that a value. It's -3, so that means that it's going to open downward. And so we still need to find the x-intercepts, and we still need to find the y-intercepts. So for the x-intercepts, again, that means that the y value is going to equal 0. So for this equation, or this function right here, I'm going to set y equal to 0. I'm going to say -3 times x plus 3 times x minus 4. And again, with this, if you want to, if you can set each factor from the 0 product property equal to 0, so we get 0 equals -3. That equation is just not going to work. That is a not true statement. We get 0 equals x plus 3, and we get 0 equals x minus 4. So our x-intercepts here, we're going to get the x equals -3, we're going to get x equals 4, and then we need to evaluate the y-intercept. So for the y-intercept, again, we do make the x value equal 0. So I'm going to punch in 0 for both of those x's right there. I'm going to say y equals -3 times 0 plus 3 times 0 minus 4. So y equals -3 times 3 times -4. So let's see, -3 times 3 is -9. -9 times -4 is 36. So we now know that this graph has x-intercepts of -3 and 4, a y-intercept of 36, and we know that it's going to open downward. So that's enough for us to get a sketch of it. So what I'm going to do is I'm going to set this to where each one of these is 4, so 4 and -4. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be 36 right there. Goes through 4, goes through like -3. Again, these are rough sketches. Mr. Price cannot emphasize that enough. These are not perfect graphs. So don't, I mean, obviously some accuracy is desired, but they do not need to be absolutely perfect. So that would be a rough sketch of that, using the x-intercepts, using the y-intercepts, as well as using that a value. So let's look at one more, and then we will continue to expand this knowledge. So now we're going to sketch the graph of the function f of x equals 4 times x minus 2 squared. So again, we've got the a value here. So a is 4, which means it's going to open upwards. And now we need to do the x-intercepts, and we need to do the y-intercept. So for the x-intercepts, we're going to set y equal to 0, 4 times x minus 2 squared. So we're going to set 4 equal to 0. That's not going to work out. We'll set both of these x minus 2's equal to 0 to get x equals 2. Now, the thing is, since this is a repeated root, this occurs twice. What that means is that your x-intercept is your vertex here. Because for something to cross the x-axis one time, like if we're looking at it this way, it's either got to touch right there at the x-intercept, or it could look like that. It has to cross one time if you only have one x-intercept. So it will only cross at the vertex. So x equals 2 is going to be our vertex there. So then the y-intercept, we're going to set x equal to 0 and solve. So we're going to say y equals 4 times 0 minus 2 squared. Let's see, y equals 4, negative 2 squared. That's going to give us y equals 4 times 4. That's going to give us a y-intercept of 16. So when we look at this, we say, okay, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that's going to reach here. And again, with that axis of symmetry that we talked about, we can go over to up 16 and get a rough sketch of that parabola. There's a couple of shortcuts that we can use to help us graph that, to help us graph it. So that is, in a nutshell, graphing quadratics using the x-intercepts as well as using the value of a. So we're going to look at a few more ways, a few more things that we can use to graph this. And we're going to start by looking at what we talked a little bit about last class, which is the axis of symmetry. So again, the graph of any quadratic function, we talked about this a little bit for last class's bell ringer. You can basically draw a line of symmetry here that is called the axis of symmetry. And so the axis of symmetry here is vertical. It is always passing through an x value. You'll usually see it as x equals k. Now, the thing that we do need to mention a little bit, we didn't get into this last class. So if a quadratic function has two x-intercepts, so if you have it here and you have it here, the axis of symmetry lies halfway in between your x-intercepts. That's a very important thing that will help you graph quadratics more easily, understand what the graphs will look like, because if you find the x-intercepts, you now have the axis of symmetry, which is also the x-coordinate of the vertex. So what we're going to look at here real quick, we've got two parabolas here. We've got two parabolas. So on this first one here, we've got an x value of 1 and x-intercept of 5. So based off of that, where would our axis of symmetry be? So to answer that, all you have to say is, okay, well, what number is between 1 and 5? To figure that out, we're just going to take the average of them. We're going to add these things together and then divide those by 2. So let's see, 1 plus 5 is 6, divided by 2. The axis of symmetry here is going to occur at the x value of 3. So if we have a situation where our parabola only touches at an x value here, so like for example here it touches at the x value of 2, we cannot we can say this is a repeated root. This means that x equals 2 occurs twice as an intercept. And again, if you use this methodology and you say, well, 2 plus 2 divided by 2, Mr. Price, well, that's 4 divided by 2, which is just 2. It still works even if there's a repeated root. But when there's a repeated root, it's a little bit easier to mentally see the axis of symmetry. So you're probably looking at that like, Mr. Price, do I really have to add those together? If it's a repeated root, you really don't. So using that, again, to find the axis of symmetry without having to add that stuff together, to surefire find it, if it's in standard form, you can just use the formula x equals negative b over 2a. And if you're wondering where that comes from, there is a very descriptive, broken down proof of that in your book. I am going to not get into that in the notes because that would personally take forever. We're looking at a little bit of like what the quadratic formula looked like, which is we're not going to get all the way into. I'm sure you all don't mind, but just to give you an intuition where this stuff is coming from. So if we wanted to find the equation of the axis of symmetry for y equals 3x squared plus 4x minus 5, the two approaches that we could do are that one, we could find the we could find the average of the x intercepts, or two, we could just calculate negative b over 2a. Either one of those will work to calculate an axis of symmetry. Now in this case, we've got a quadratic where the a value is larger than 1. This doesn't look like it will factor very easily. So we'd probably, if we want to get the x-intercepts, we would either have to complete the square or use quadratic formula. So in this case, let's calculate negative b over 2a. So again, this is like the a value, the b value, and the c value. So we've got what? Negative b, so that's going to be negative 4 over 2a. So over 2 times 3, we've got negative 4 over 6, or negative 2/3 equals x. This is our axis of symmetry right there. That's our axis of symmetry. So the last thing that we're getting into for today is talking about the vertex of a parabola. So the vertex, or you may hear this called the turning point of a quadratic function of the standard form y equals ax squared plus bx plus c. This is the point that the function is either a maximum value, if it's the highest point, we refer to it as a maximum, or a minimum value if it's the lowest point. So the vertex of a quadratic function always occurs wherever the axis of symmetry is. All of this stuff relates to one another. So basically, if you get the axis of symmetry, which is the x-coordinate of the vertex, all you have to do to find the y-coordinate of the vertex is to substitute that x value into your function. So whatever quadratic function that is at that time, you just got to substitute into it, and then you're good to go. So we're going to look at what that looks like practically, and then apply it to a couple of quadratics, a couple of parabolas. So we want to find the coordinates of the vertex for x squared plus 6x plus 4. So to get the x coordinate here, it is negative b divided by 2a. So we've got a is 1 here, b is 6, and c is 4. So we've got x equals negative 6 over 2 times 1. So that's going to give us an x value of negative 6 over 2, or x equals negative 3. Now, to get the y value of this, we're going to do f of negative 3. So that means we're going to replace every x that we see with a negative 3 here. So negative 3 squared plus 6 times negative 3 plus 4 here. And so what that is going to look like for us, we're going to say, alrighty, well, that's going to be negative 3 squared, which is 9, minus 18, plus 4 is f of negative 3. 9 minus 8 is negative 9, plus 4 is negative 5. So our vertex here for this function is going to be negative 3, negative 5. And since this is an a value of 1, this would be a minimum value. Since this parabola is going to be facing upward, it would be a minimum value. So let's put all of this information that we've talked about in the notes all together. Let's use all of this information to graph to graph a parabola. So here we've got the function y equals negative times x plus 5 times x minus 1. So we want to find the axis intercept. So we want to find the x-intercepts and we want to find the y-intercepts here. We want to calculate both of these things here. So the x-intercepts, we're going to set y equal to 0. So we're going to say 0 equals negative x plus 5 times x minus 1. So then that means x plus 5 equals 0, x minus 1 equals 0. So that means x is going to equal negative 5, and x is going to equal 1. For the y-intercept, we set x equal to 0. So we're going to say y equals negative 0 plus 5 times 0 minus 1. So that's going to be negative 5 times negative 1. That's going to give us a y value of 5. So those are our axis intercepts. So that's a key part to helping us graph this. So the next thing that we need to do is we need to find the equation of the axis of symmetry. So if you're looking at this equation, you're like, Mr. Price, what's A, what's B, what's C? You can decide that you want to FOIL those out if you want, and then do negative B over 2A. Or if you remember, the axis of symmetry occurs when between the average of these numbers, between the middle of negative 5 and 1. So to find the middle of these numbers, all that you have to do is combine, you have to find the mathematical average of them. So negative 5 plus 1 divided by 2 is going to give us negative 4 over 2, or just x equals negative 2. This is our axis of symmetry here. Our axis of symmetry. So now we want to find the coordinates of the vertex here. We want to find the coordinates of our vertex here. So we've got the x value here, but we need the y value. So what we're going to do is we're going to take this x equals negative 2. We're going to substitute it back into our original function. We're going to say y equals negative times negative 2 plus 5 times negative 2 minus 1, and then we're going to evaluate this function. So we'll say y equals negative, let's see, negative 2 plus 5 is 3, negative 2 minus 1 is negative 3, negative times negative 3 is negative 3 times negative 3 is y equals 9. So our vertex here has an x value of negative 2 and a y value of 9. X value of negative 2, y value of 9. So now, with all of this information that we have discovered, we want to now create a graph of this function. So I don't have a ton of room here, but I'm going to give as accurate of one as I can get. So we got negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Plotting that vertex right there, I know it's going to cross 3, 4, 5 at negative 5 and at 1. And I know it's going to have a y-intercept of 1, 2, 3, 4, 5. And I'm going to sketch this graph right here for this parabola. Now, the last thing, kind of just to rehash on an older concept, we want to talk about what the domain and the range of this function is. Now, as a reminder, the domain is all of the possible x values. The range is all of the possible y values. So the domain here, the lowest x value that this can be, we got this arrow going all the way to the left. It can go down to negative infinity here. And then we see if we trace it to the right, this arrow keeps going to the right for forever. So we go negative infinity to positive infinity. Now for the range, we see the lowest y value that can occur here. Both of these arrows are going down. So we're going to hit negative infinity. We're going to put a parenthesis on that. Parentheses mean, again, it's not included. We can't include infinity because there's always a number that's lower than it. And then the highest y value that this graph gets to is here at the vertex. It's the highest value for the y at the value of 9, and we're going to put a bracket on that. So that is our lesson today on features of parabolas and using those features to graph these different parabolas. If you all have any questions, please let me know and we can look at it together. Otherwise, have a good rest of your day, and I will see you all on Thursday.